number 3, we have the limit as x approaches 0 of x over x squared minus x. So the very, very first thing you have to do is show that it's the indeterminate form. You do. So you have to show it's indeterminate. And then what we want to do is say, okay, algebraically, I can factor out an x from the denominator. And then that equals the limit as x approaches 0 of 1 over x minus 1. So what that means is this function here behaves like this function here. It means that as we cancel these x's, they are what we call a removable whole, which we're going to talk a lot about on Friday and following. So therefore, this is 1 over 0 minus 1, or negative 1. Yes. Yep. The quiz is tomorrow. It's just a quiz. There's one, yes. And there's one on this other. I have another review for you, but I stapled 2 at the answer key. So this, instead of giving you homework assigned tonight, you have this as practice with my answer key and all my handwriting stapled. So you have no homework. This is just like an optional review guide for you with an answer key. And there is an example like it on there. You do not have homework. All right, flipping to station 2. Do you want to do 1 or 2? Yeah, we're doing 1 or 2. Do you want 1 or 2? All right, so again, when we see this one, we're automatically, I know you're in your head going, complex conjugate. And it is true, because if you plug in 3, you get the square root of 4 minus 2 over 3 minus 3, which gives 2 minus 2, which is 0, and 3 minus 3, which is 0. So we know that this needs to be done using the complex conjugate. The complex conjugate is the difference of squares partner to the numerator. So we're going to multiply top and bottom by square root x plus 1, but plus 2 instead of minus 2. Don't FOIL your denominator. So you get the limit as x approaches 3. Square root x plus 1 times square root x plus 1 is x plus 1. Square root x plus 1 times 2 is 2 square roots x plus 1, but the middle is negative 2 square roots of x plus 1. So they cancel. Negative 2 times 2 is negative 4. Yep. Nope. All over x minus 3 times square root x plus 1 plus 2. Notice how I keep them grouped in parentheses. I don't want to multiply them. The reason for that is because here, plus 1 and minus 4 makes my numerator x minus 3, and that cancels nicely with that denominator. So this is equal to the limit as x approaches 3 of 1 over square root x plus 1 plus 2. Now I plug in my number. When I plug in the number, I no longer rate my limit. So the limit's here, but not there. You must rate your limit until you plug in the number. So you should have a limit as x approaches 3 in front of all your algebra. That's why I'm giving reminders today. So we get 1/4. You would multiply. So for number 1, just your complex conjugate in number 1 would be the square root of x plus 5 plus square root 5. It would be, the first part would become, when you multiplied it, the first part would become x plus 5. And then square root 5 times negative square root 5 would become negative 5. Yeah, the numerator eventually will become x. No, I left mine as a perfect. Yep, that's what I had. Okay, let's go to station 3. Okay, that's fine. Number 1's a good one. We can even do more than this. We have all of class time. So I just want to hit one of every station. And then I will gladly go back and do anything you want to do. Okay. So think about number 1. Let's look at 1. It's the limit as x approaches 0 of sine 5x over 4x. It is. It's a manipulation of sine x over x. But the problem is that what is in the bottom has to match what's up top. So right now we have a 5 and a 4. But remember that like this can really be thought of as like 1/4 times sine 5x over x. If I'm missing a 5, how do I get a 5? Yeah, so we're going to multiply by 5 over 5. So now you have the limit as x approaches 0 of 5/4 times sine 5x over 5x. So since the coefficient inside matches the coefficient in the denominator, that limit as x approaches 0 of sine 5x over 5x becomes 1. All right, how about, let's look at station 4, number 1. Sine x over x is 1. At 0. It is a lot of memorizing. All right, so on the back for the piecewise, it's the limit as x approaches 3 from the left. So what you have to do is look at that problem and say, okay, this is x values less than 3. So if I'm looking for the left, I'm plugging into this function. X values greater than 3 would be the right. So for the left, we're plugging into the top, which is x plus 2 over 2. So you get 3 plus 2 over 2, or 5/2. Then the limit as x approaches 3 from the right says we plug into the bottom function, which is 12 minus 2x over 3. So the left-hand limit is 5/2. The right-hand limit is 2. Therefore, exactly, the limit as x approaches 3 of f of x does not exist. Exactly. Which one does 3 equal, the top or bottom equation? Therefore, it's the left-hand limit, which is 5/2. No. Okay, so that's stations 3 and 4. Station 5 is a graph. What? I hope so. Let's just quickly go through some of these then. Number 1, the limit as x approaches 2. So here's 2, perfect. Number 2, f of 5. Perfect, it's where the closed circle is. Number 3, the limit as x approaches 0. Number 4, the limit as x approaches 5. Does not exist. Left-hand limit is -1, right-hand limit is 1. Therefore, it does not exist. 5, the limit as x approaches 7 from the left. From the left. Number 6, f of 2. Good. It's undefined. It's not, does not exist. All right, number 7, the limit as x approaches 7 from the right. 1. And the limit as x approaches 7 does not exist. 9. At what x values on f of x does the limit of f of x exist, but f of x is not continuous? We haven't talked about this yet. Perfect. At x equals 2. Okay, bonus. What's the domain of f? All real numbers. Okay, if you say that, then what do you have to add to that? There you go. Perfect. It's all real numbers except 2. Now be careful because these have endpoints. It's not all real numbers. Yeah, it'd be -2 to 11. Yeah. Yep. So you could rate it either way. -2 to 2 excluding 2, or all reals from -2 to 11 except 2. So on 9, it's kind of like 10. The limit exists, but there's no point value. Therefore, it's not continuous, but the limit exists. For 9, just x equals 2. Because the limit exists and is -1, but f of 2 is not defined. Yeah, I was going to flip over and look at some of station 6. Oh, you want to pick the number? That's the one I was going to pick. Oh, you're so smart being dumb. All right. Number 2. The limit as x approaches -1. And this is one of those function compositions that we were kind of struggling with the other day. And the other teacher agreed with me. She got 2. But like the other teacher said 1. So now we really don't know. Because we both disagreed. So we're all sort of jumbled. So I decided that was a bad question. And I would never ask one like it. It was from the other day in class. You were on the Zoom. It was frustrating. So then I literally texted like a bunch of other teachers, and then we were like all debating too. So nobody can agree on an answer. Like our text thread was like 40 messages long, and everybody was like sending pictures of their work, and like we just didn't agree. So I was like, I'm done. I hate this question. All right, so in this problem, you start on the inside. So we start with the limit as x approaches -1 of g of x. So g of x is here, exactly. So the left-hand limit is -infinity, and the right-hand limit is infinity. Exactly. Does not exist. No. So as soon as you get this, it's this. No, because like that's more me showing you kind of what we were discussing. That like, okay, if you replace G with U, these are just like 2 ways to do it. These 2. And this. Yep. Which one do you want to see? All right, let's talk about 3. F of x is the inside function what we want to find 0. So the limit at x of 0 is -1. Because now when you want to find the limit for g, you have to go from the value you got on f of x, which is -1. So you're finding g of -1, not g of 0. Oh, so you did it with like g of 0, which was 3, and then you did f of 3. So did you have 2? Okay. Okay. I get what you mean by they switched it. Not that like they switched your limit here, but that like they switched the order of f and g. Got it. But are we feeling better about these now? The number 3 is really awesome. That's a fair question. Do you want it? So you said you struggle with like the trig ones. So do you want to go back and look at something from station 3? All right, let's look at, and I have another handout too with a bunch of problems that I was going to give you and let you pick problems you want me to do with you. Yes, and that's what's on this handout here. Here, I'll let you see this while I pass them out. So let's look at this handout and tell me if there's any you would want to do from here. This is just like an infinite. These are going to be the ones that equal infinity. This one for so sine of 0 on the unit circle is 0. Sine of yes. Yep, that's so at this point you're simplified. So now you just plug in because sine of 0 is 0, cosine of 0 is 1. So 0 over 1 is 0. And this sine x over x is 1. So like they just split into our rule we know and then into something we can find. Right? So looking at that handout with the limits on it, any of those you want to see? Yeah. All right, so for number 2, it is the limit as x approaches 2 from the left of x plus 3 over x squared plus x minus 6. So what happens is if you plug into 2 plus 3 is 5. 2 squared is 4 plus 2 minus 6. So you get 5 over 0. So the minute you get 5 over 0, Deja, I gotta print you one. I have no idea why I only have 4 copies. So just give me a second because I don't have it readily available to print. So we have 5 over 0. Anytime you get a number over 0, you need to think vertical asymptote. Okay? Which means your limit is going to be an infinity. So if we're looking at the limit from the left, you just need to determine, is it going to be positive or negative to the left of 2? So if you get 5 over 0, it's a vertical asymptote, which means your answer is an infinity. So if 2's here, I need to plug in 1.9. So if you plug 1.9 into the top, you're going to get a positive. If you plug 1.9 into the bottom, you just need to know if this is going to be bigger or smaller than 6. So 1.9 squared is less than 4. 1.9 plus something less than 4 is going to be like 5 something. 5 minus 6 is going to be negative. Therefore, this limit is negative infinity. Because this isn't factorable. Oh, maybe it is. No, it's not. But it won't cancel. Right. It's not a, yeah, it's still a vertical asymptote. Anytime you get a number over 0, it means that the algebra isn't going to help you. A number over 0 automatically implies a vertical asymptote. A horizontal asymptote all has to do with a comparison of the powers of the exponents. So like in that one, the numerator is 1 less than the denominator. So there's no vertical asymptote. Or there's a vertical asymptote at 0. Sorry, horizontal, truthfully, sorry. Yeah. No, at -3, it's removable discontinuity. It's a whole. So you know when you said you factored x plus 3, x plus 3, x minus 2, this becomes a whole. This is your vertical asymptote. So the wholes cancel. X equals -3 is not a vertical asymptote. It's a whole. Exactly. So that's what I was saying. Both. The answer to your question is both. Like, technically, yeah, because even if you simplified and canceled, you still end up with 1 over x minus 2. And when you plug that in, you still end up with 1 over 0, which still is a number over 0, which is a vertical asymptote. Yes. It was given to you as that. The problem was find the limit as x approaches 2. Like, I didn't just pick, like, that was the, here, Corey, this is a review with an answer key if you want practice tonight at home. I mean, they could have also picked the limit as x approaches -3 because they would have maybe wanted you to find the whole. So if you'd have plugged in -3, you'd have got 0 over 0. And then you would have wanted to simplify to this. And then you would have gotten 1 over -5. So you'd have gotten a different answer. Both are still valid limit questions that I could ask, just totally different concepts. Yeah. Yes. Like it would have looked like. And then you would have still simplified. Your answers are different. The answer is x approaches 2 from the left is -infinity. The limit for this is x approaches -3 is -1 revenge. After you factor. Because if you plug it in at the beginning, you get 0 over 0, which is the indeterminate, which tells you you could factor. What I was saying is if you plugged in 2 from the beginning, you get 5 over 0, which implies a vertical asymptote. So that's the difference. A number over 0 is a vertical asymptote. 0 over 0 is indeterminate, which tells you to do some algebra. Yes. Yeah, you could say I don't care. I might All right, Alex. But I like to talk about them. But Tasia, please.